10 years later, in 1881, one of the most famous experiments ever performed was about to add even more controversy to the heliocentric-geocentric debate. Albert Michelson, a world-class physicist, had invented the interferometer, a machine designed to measure the interference patterns of two light beams moving against each other. Its principle was similar to Foucault's experiment, but it was much more sensitive. Instead of sending the light beams in parallel paths through water, Michelson sent them in numerous perpendicular paths through air on a rotating table, which would allow a more comprehensive and accurate test. Michelson directed one of the light beams toward the west, since this is, as everyone believed, the direction of the Earth's movement around the Sun. This would automatically point the other beam toward the North Pole. Hence, the light beam going west would head right into the ether at the supposed speed of the Earth around the Sun at 66,000 miles per hour, while the light beam going north would experience very little or no ether resistance. When the light beams returned to the receiving plate, Michelson assumed, based on the then reigning Fresnel drag theory of ether, that the westbound light beam would travel slower and come back later than the northbound light beam, due to the pressure from the ether on the westbound beam. If we picture the light beams as particles, then if the westbound beam was slower, the particles of the two light beams would not coincide when they finished their respective routes in Michelson's interferometer. The north particle would be ahead of the west particle by a wide enough margin that the difference would mean the Earth was revolving around the Sun. Thus, Michelson expected the north particle and the west particle to be separated by a wide margin. If we assume the light beams are waves, then, if the Earth were revolving around the Sun, Michelson expected the waves to be separated by a wide margin.
But to his astonishment, Michelson saw only a minuscule of separation between the waves. The wave peaks and troves were very close together. Under the physics of that day, Michelson's results strongly suggested the Earth wasn't moving. Hence, what Arago and Airy found examining starlight was now confirmed by Michelson with terrestrial light. By all experimental indications, the Earth was standing still in space, and modern science was confronted with its most astounding yet devastating evidence that had the potential to destroy its very foundation.